Okay, anybody, what's up, Charles? Anybody remember what we were talking about last time? Talking about sequences, that's right. And we talked specifically about geometric and arithmetic sequences, right? So we're going to continue that conversation today. Who am I missing? Looks like I'm missing someone. No one over there. Oh, Sophia, oh yeah, she's on that retreat. And Julia, I don't know, I thought I saw Julia. Okay, all right, so today we're ready for this page called Find the Limit of the Following Sequences. All right, we're going to find the limit of the following sequences. Everybody see it, number 6? All right. Now, when we look at a set of numbers, there are a couple of things that can happen. One of the things that can happen is this set of numbers just continues to get bigger and bigger and bigger just forever. So let's look at that first sequence. Would you agree that if we continued 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared. What are you doing here? Seriously, where are you supposed to be?
I don't have any class right now.
Okay, you have somewhere you're supposed to be.
I don't have to be anywhere, Miss Ford. I just love math so much. I try to get to
I do too, Dre, but.
All right, see you, Miss Ford.
Okay,
Love you.
honey. Love you too. Oh my goodness. So 6 squared, 7 squared, 8 squared, and so on. What's happening to these numbers? They are just going to continue to get bigger and bigger and bigger. So we describe that, the way we describe that is we say it has no limit.
6.
Okay. Or we can say infinity. Now, the best thing to say is no limit, but since this one does increase forever and ever and ever, you can say no limit. You can say infinity. You can also use the word divergent. The word divergent means what? Have you heard that word before? Diverge. Things diverge. That means they just go, right? They don't head toward anything. That is very different than what happens in question B. Look at those numbers. 1/3, 1/9, 1/27. What would come next? Oh my, we need to be able to tell what comes next. What comes after 1/27? 1/81. 81. Where did she get 81? 27 is 3 times 3 times 3. So she multiplied by another 3. And so the next one would be 1/81 times 3. What is happening to these numbers? They're not getting bigger, they are getting smaller. If I put them on a number line, isn't this what would be happening to them? Now, they're getting smaller, true, but they're not getting infinitely smaller. In fact, they're not going off the number line. What are they getting closer to? As I plot them, they're getting closer and closer to 0. So the limit is 0. And the way, we'll just say the limit is 0. We're going to learn how to write this a little bit better. But for now, we're just going to say the limit is 0. Tell me about C. What do you think is happening in C? Look at those numbers. Think about what would come next. What are they doing? They're being multiplied by -2. Okay, so what's happening to them? Are they getting closer to 0? Are they heading off the number line like our first one was, like A was? A, the numbers just kept going, going, going. What's happening to these? They are going
back and forth. But every time they go back and forth, they get further out. That is either the words no limit or divergent. It isn't going anywhere except farther out, but it's going farther out in both directions. So you can't say infinity. Infinity would be going farther out that way. This one's back and forth, divergent. Now, D, this is where we're going to start using our correct notation, all right? So our notation is going to look like this. We're going to take the limit of our sequence, which is written a sub n, that's our sequence, the limit of our sequence as n approaches infinity. We're letting n get bigger and bigger and bigger and bigger going down the line. Let's look at these numbers and see if you can figure out the limit. The thing is n over n plus 1. So if I put in a 1, what would I get? If I put in a 1, 1 over 2. All right, that would be my first term. Let's put in 2. 2 over 3. Let's put in 3. 3 over 4. Oh, let's skip ahead. Let's put in a 10. What do I get if I put in a 10?
10 over 11.
10 over 11. What do I get if I put in 100?
100 over 101.
100 over 101. If I put in 1,000.
1,000 over 1,001.
Okay, we got the hang of this. Can you tell me what's happening to these numbers?
Plus 1.
What?
Plus 1.
Well, the denominator is 1 more than the numerator, that's true. But what is happening, let's say decimally? Type in 10 divided by 11. Then type in 100 divided by 101. Then type in 1,000 divided by 1,001. What do you observe about what's happening with these numbers? Are they getting bigger or smaller? They're getting bigger. Are they gonna go off the number line bigger? No, what are they getting closer to? 1. The limit is 1. Now I'm gonna show you something that ties in to something you already know, so that you don't have to go through this trial and error process anymore. And when I look at this right here, let me think back to when I was graphing these, remember putting in asymptotes and all that stuff? Does anybody remember how we found the horizontal asymptote or something like this? The horizontal. Do you remember?
The bottom.
Not just the bottom. Is that what you said?
X's?
You use the X's, we boxed them in, that might be what you said, Ashley, I'm sorry, we boxed them in. So where would the horizontal asymptote of this problem be? 1, that's the limit. So you're gonna find the limit the same way that you find the horizontal asymptote. So next time you do this problem, you're not gonna have to write all this out. You're gonna look at n over n plus 1 and say n over n is 1, and that's gonna be your answer. So with that in mind, what do you think the limit for problem E is? E. Two-thirds. Why is it 2/3? Because it's 2n over 3n. That's how you do it. Remember, those of you that slept through that chapter, I'm sorry, you need to know this. You box in 2n over 3n, that's your horizontal asymptote, and it's already it's also your limit. All right, what about f, do you think? What is the limit of f? 4 over 5. We always look at the biggest power, remember? It's the biggest power. So we're looking at the n squareds there. So 4 over 5. Okay? How about G? 0, very good, Mackenzie Land. Why is it 0? Exactly. Remember, you have to compare the same power. So, since we have n minus 2 over 5m squared plus 6m plus 3, this is the power I have to look at. I don't have any on the top. So when I box it in, I get 0 over 5, which is 0. So the answer to G is 0. What about H? It's the opposite. No limit. No limit. Because if you compare the n squareds, you would have 8 over 0, and you can't have 8 over 0. So no limit. All right, so problems D through H. Are we good with that kind of problem? When it looks like that, you box them in, you're good with that. Problems I through L look different. Okay? They are not, I mean, there's fractions involved, but they're not fractions like n's over n's. They're a number to a power. Now remember, we're finding the limit as n approaches infinity. So this means that n is going to get bigger. Okay, so you can start with 1 and 2 and 3, but eventually you're going to be like at 100 and 1,000. It just keeps going and going. So take out your calculator and just for fun, type in 2/3 to a power. Make it a big power, like 2/3 to the 50th. Error?
Mine might
Did it
also-
say error for everybody?
Well, I might have also just put a really big number.
No, that didn't, yeah, it's 2/3 is a fraction, you have to have 2/3 in parentheses. So 2/3 in parentheses, what did I say, 50th power? 1.568 times 10 to the negative 9. Now, guys, I need you to pay attention. What kind of a number is times 10 to the negative 9? Is that a big number? No, that is a very teensy number. Do 2/3 to the 100. What happened? It got even smaller. So as n gets bigger, what happens to this number? It gets smaller. Now, is it ever going to be negative? No, it's just going to keep getting smaller and smaller, so its limit is going to be 0. In general, try to remember this. If you have a number less than 1, every time you multiply it, you're going to get a smaller answer. If this number is less than 1, the limit is always going to be 0. It doesn't matter if that's a 3/4, a 7/8, a 9/11. If that number is less than 1, every time the limit's going to be 0. Every time. So when I look at problem L, what is the answer to problem L? 0. Because 0.8 is less than 1. But Ms. Ford, look, that exponent looks different. Who cares? No one. If you are raising a number less than 1 to any power, any positive power, you're going to go to 0. Okay? So I and L both have a limit of 0 because 1 is 2/3 and 1 is 0.8. Those are less than 1. Okay? Now, what happens when it's bigger than 1? Well, let's try J. Forget the n minus 1 for a minute. Just take 5/4 and raise it to the 50th power. What happens when you raise 5/4 to the 50th power? 70,064 point whatever. Okay, that's not a gigantic number, but it's pretty big. Let's take 5/4 and raise it to the 200th power. A really big number. I got times 10 to the 19th. Okay, so what's happening? With a number like 5/4, did you put 5/4 in parentheses?
No.
If you raise 5/4 to bigger and bigger numbers, it just keeps getting bigger. What's so these have no limit.
Oh, okay.
This one has no limit, it is divergent. These problems that are a number raised to a power, your answer, if you find no limit, your answer will always be 0 or no limit, every time. What is the key? If that guy is less than 1, your limit is going to be 0. If that guy is more than 1, you aren't going to have a limit. Those are your only two options. It's either 0 or it's no limit. And again, the key is that guy right there. I don't care what the exponent is, forget it. Look at this right here. If that number's less than 1, 0 is the limit. If that number's bigger than 1, there is no limit. Divergent means no limit. So, tell me about problem K. What is the answer to problem K? Divergent, no limit. Divergent. Okay? All right. So 9/4 should of course be due Friday, but we're at school. We're not school on Monday, so it's due on Tuesday. So 9/4 is due on Tuesday, and we are going to start 9/5 right now. All right, so what's happening in 9/5? Find the sum of the following series. So what does sum mean? What does sum mean? Atom, right? So one option we have is to simply take our calculator and add up all those numbers, right? That would be one option. All right, so go ahead and do that and tell me what you get. And then I'm going to show you another way to do that problem. You're adding them up. I got a -4 as one answer. Anybody else get -4? Perfect. Now, kids, you can do that, right? I mean, every time, that is perfectly acceptable. If you just want to take out your calculator and start adding. Luckily, we only had 1, 2, 3, 4, 5, 6, 7, 8 numbers to add up. Imagine if there were 100 numbers to add up. You could still do it, it would just take a long time. So just like yesterday, there are formulas that will help you add things up. Okay, what kind of sequence is that? We didn't clear that up. What kind of sequence is this? Is this arithmetic or geometric? Arithmetic. The common difference is 5. The formula for an arithmetic sequence is to add them, to find the sum, is this. Okay, so this is your arithmetic sum formula. Okay, Now I'm gonna show you how this formula works. I wanted to add up this set of numbers. You already determined that there are 8 of them. So this number tells me how many I'm adding. Yesterday, when I had a sub 5, that's meant the 5th number in the line, the 5th term. This means you're adding up 8 numbers. But that n right there, that 8 is the same as this, is the same as that. So I can already say 8 over 2, a sub 1 plus a sub 8. I am adding up 8 terms. All of these n's are 8s. Okay, so I've got 4 out in front. All right, who remembers from yesterday? What does a sub 1 stand for? First term. Well, the first number is negative 18. What does a sub 8 stand for then? The 8th number, which for us would be the last number. So what's negative 18 plus 7? Negative 18 plus 17? Negative 1. And what's 4 times negative 1? And what did we say the answer was? Negative 4. So if there had been 100 numbers in a line, I would have done exactly the same thing. Easy peasy. So I know that, oh wait, shoot. I was gonna say, let's use our formula for problem B, but what do you notice about problem B? It's geometric. So you're not using that formula. That formula is for arithmetic. Remember, you don't need to memorize the formulas, but you need to know which one to use when. So this is a sum formula, and it is arithmetic. Now I'm going to give you the sum formula for geometric. You do not have to memorize the formulas.
Sorry, it's your name.
But you have to know that that one's arithmetic and this one is geometric. Now this one at least has R's in it, and that kind of reminds you of geometric. But you gotta remember that. I know you can type these in on your calculator, but let's see if we can use our formula for problem B. How many are we adding in problem B? We are adding 5, so S sub 5. Now what does S sub 5 equal? What's that?
The first term.
Which is?
Negative 2.
So negative 2 minus, and we got another one, times the ratio. What is the ratio in this problem? What are we multiplying by as we go down the line? 3. And then you're going to raise it to the nth power, but you already told me n was 5. And then you're going to divide that by 1 minus the ratio. Now, I always do this first, okay? So I have negative 2 minus negative 2 times 3 to the 5th over negative 2. If you do that first, then you can just type the problem in. You don't need to worry about parentheses and all that. So negative 2, make sure you're using your negative button, minus negative 2 times 3 to the 5th equals divided by negative 2. Negative 242 is exactly right. So if you didn't get that, try it again. Make sure after you type in all the numbers on the top, and you're going to type exactly what I wrote. This is a minus. That's your minus sign. These are your negatives. You're going to type it all in, hit equals, and then divide it by negative 2. after you hit equals, gotta hit equals, and then divided by -2. All right, everybody getting -242? Perfect. All right, let's look at the next one. What is going on with the next one? What do you notice about this one?
It has a total.
It has a gap in it. So what does that mean if there's a gap in it? What do I not know?
17.
I don't know how many terms there are in this list, because I'm missing a chunk of them, right? And, well, would you say it's arithmetic or geometric?
It's
Arithmetic. So I know I'm gonna be using this formula. In order to use that formula, because this is arithmetic, the difference is 4, adding 4, right? In order to use that formula, I need to know what n is. I need to know how many terms I'm adding up. And I don't have that information. That is gonna happen to you a lot with this formula. When you don't have the information you need to answer the question, then you have to go back to yesterday's arithmetic formula and get the information that you need. Now kids, I know this can be a little tricky, so try to pay attention. You'll get it, it's not hard. It's a two-step problem. So I'm gonna go back to yesterday's formula. This was yesterday's. It will be written on the board with you. I do not know what n is, but luckily, I know everything else. I know my first term is 5. I know my common difference is 4. And I know that the nth term is 53. That's the last term in the line. I don't know whether it's the 19th term or the 52nd term. I don't know which one it is, but it's the last term in the line. So the nth term is 53. Can I solve that equation for n? Yep, and that's what I'm gonna do. That's gonna tell me what n is. So 53, well actually, let's do this. Let's subtract the 5. So 48 equals 4 times n minus 1. Now you can either distribute or you could just divide by 4. So however, whatever order you want to solve that equation in, you need to solve this equation, algebra 1. Solve that equation. You can distribute, multiply terms, do whatever you want. I subtracted 5, divided by 4, added 1. That's what I did, but you don't have to do it that way. But you do have to get 13 as your answer. So what does that mean? There are 13 numbers in that list. So now I can use my formula. There are 13 numbers in the list. The first one is 5, and the last one is 53. This formula is one of the easiest ones to use, but unfortunately, you often have to do another formula first. So, what is that? 13 over 2 times 58? I got 377, but I don't know, did I do that right? That's right. And this is your final answer. The 13 was not your answer. The 13 was the number that you could plug in to get your answer. You all look a little dazed. All right, anybody have a question about that before I erase? other formula from yesterday? You don't have to memorize it, I just thought maybe someone remembered. Do you remember what the other one is? Do you have it written down? Luckily, I have it written down, so I got it. Okay, let's look at the next one. We're adding them up. What's the first thing you should be thinking about? Other than, "Oh, I can't wait till this is over." Other than that, what is the first thing you should be thinking of when you look at this problem? Is it arithmetic or geometric? Because that decision is gonna tell you how you're gonna proceed, right? So what's your determination here? Are we arithmetic or geometric? If we're geometric, you're telling me I'm multiplying by something. What am I multiplying by? 5. You're exactly right. The ratio is 5. Yesterday, a student was having a trouble determining whether it was arithmetic or geometric. If you take 0.4 and divide it by 0.08, and then you take 2 and divide it by 0.4, if those match, those numbers match, then it's geometric, and that number is the ratio. If you subtract 0.4 minus 0.08 and 2 minus 0.4, if those numbers match, which they don't, but if they did, then it would be arithmetic, and that would be the common difference. All right, so we're geometric. That's this formula right here. So what do we need to know to use that formula? Well, we need to know the first term. Do we know the first term? So 0.08 minus 0.08. Then we need to know the ratio. Do we know the ratio? Yep, it's 5. You figured that out. Oh, shooty. What else do we need to know? How many there are? And I have that gap again. I don't know how many there are. Now, you have a choice. Could you keep timesing by 5? So the next term would be 10, and the next term after that would be 50, and so on. Could you just keep doing that? Could you fill in the gap, in other words? Absolutely. And then if you filled in the gap, you could count them up. That works, and it's perfectly okay to do it. I want you to get used to the formulas. I mean, that's my hope, in case there's, like, this is bigger. So how would the formula work? Well, I go back to my other formula. My last term is 1250. My first term is 0.08. My ratio is 5, and I'm raising it to the n minus 1 power. That is what I don't know. That's what I'm gonna figure out. So step 1, I'm going to divide 1250 by 0.08. I'm going to divide both sides by 0.08. So 5 to a power equals 15625. That's a big number. I have no idea how many 5s it takes. You know, like 5 squared is 25, and 5 cubed is 125. I don't know how many 5s it takes to get this. So I can either use logarithms, or I know, Mackenzie says, ugh, or I can just kind of trial and error it. What's 5 to the 6th power? oh my gosh. I guessed. That was really truly a total guess. I guessed, and that's it. So 5 to the 6th is 5 to the n minus 1. This guy right here is 5 to the 6th. So what does n have to be? 7. So now I can come back and put 7 in there and finish my problem. Now I know what you are thinking. You are thinking, oh, I would much rather just fill in the gaps. And again, that's okay. But understand, if there's 1,000 terms, that's gonna take you a very long time, and you don't get extra time on the test to do that. Okay, is everybody clear on that? So it's perfectly okay to do it. But you have a finite amount of time, and you gotta work within that time. Okay, now let's type, where am I? Let's type this into our calculator. And again, I do this first. So 1 minus 5, I'm gonna make that negative 4. All right? 0.08 minus 0.08 times 5 raised to the 7th equals divided by negative 4. So did you get, Jordan, 1,562.48?
Yes.
That is the answer. It's kind of unfortunate, but we often have to use, when we use these formulas, especially that one, we often have to also use one of these to get whatever information we need. All right, you ready for the number 2? No. Yes, we're gonna be ready for number 2. Here we go. What does number 2 say? Find the sum. So I know I'm going to be using one of these. These are my sum formulas. Find the sums of the first 90 terms. N is 90. I am finding the sum of the first 90 terms. What is the matter with you? What is going on
There's
over
a
there?
bug. It's like in my. It's like it won't leave me alone.
Where is it?
It's gone now, but Daniel saw it, so I'm not crazy.
Well, is it just a little bug?
Yeah, but it's like on, like it gets on, like it's right here, and I can feel it.
Okay. Maybe my bananas are bothering you. Is it like a gnat?
It's like bigger than a gnat. It's like, yeah, it's like a moth. Like moths can come out in the day.
Okay, let's try to get back to work here. All right, so find the sum of the first 90 terms. Question 1. Arithmetic or geometric? Charlie. Arithmetic or geometric? Okay. Okay, well, first of all, you're a terrible guesser. You had a 50-50 shot and you missed. But you should be able, Charlie, to look at the sequence. What is happening? How are we getting from term to term? Plus 3. Charlie, if we're plus 3, we're arithmetic. Okay? So this guy is arithmetic, and the difference is 3. Would everyone agree with that? Okay. That means this is my formula right here. That is my arithmetic add 'em up formula. So the sum of 90, according to the formula, will be 90 over 2 times, what's this?
-2.
-2 plus, oh no. What goes here? A sub 90? That's what that says, A sub 90. What does that mean? A sub 90 is the 90th term. So if I would have to keep going all the way out to the 90th, Okay, bad idea, I don't wanna do it. How could I find the 90th term without doing that? Won't this tell me the 90th term? So over to the side, the 90th term, we're using this one now, I'm running out of symbols, we're using that one now. The 90th term would be what? -2 plus 3 times 89, beautiful. And minus 1, 90 minus 1. So, -2 plus 3 times 89 is 265. Does 265 go in the answer blank? No, where does 265 go? Right here, right? Right there? So now I have 265 plus -2 times 90 over 2, 45. Your final answer to the original problem is 11,835. So, 2 steps. Why did I use these 2 formulas? Of my whole list, why did I pick these 2? Because they're arithmetic. The sequence is arithmetic. Okay? This was my answer, but I didn't have that number, so I had to use this formula to find that number, and then I could get my answer.
Wait.
All right, I need to leave my formula, so I'm gonna erase this. We okay with this? I know it's a lot, but you know what? We gotta figure it out. We gotta keep going. I have confidence.
There was no division.
All right, let's see what we got here. 0.1, 0.2, 0.4, dot, dot, dot. And it's 12. Directions say add them up. I need S sub 12. I'm going to use one of these 2 formulas.
Oh, I know what I
S is my S formulas. And which one I use is going to depend completely on what? Whether it's arithmetic or geometric. So let's see if we can figure that out. How are we getting from term to term? Times 2? Times 2? Times 2? Times 2? So this is geometric and the ratio is 2. So now I'm gonna pop over geometric. I'm using this formula. This is my geometric formula. S sub 12, and this 12, S sub 12 equals 0.1 minus 0.1 times 2 to the 12 over 1 minus 2. I have everything. This is just a plug and chug problem. I don't have to do anything fancy. I know my first term, I know my ratio, I got it. So this denominator is -1, so I always do my denominator first. Then I will just put in 0.1 minus 0.1 times 2 to the 12 equals, you gotta remember to hit equals, divided by -1. Did you get 409.5? Okay? So you got 4 formulas so far. We're getting ready to get our last one here in a few minutes. How do you know which one formula to use. All these things are written up here. How do we know which one to use? Well, you have to know if you're arithmetic or geometric, because the pink ones are arithmetic. So if you have an arithmetic problem, you are going to be using the pink ones. If it's geometric, you'll be using the other ones, right? So let's say I have an arithmetic problem. How do I know whether I'm using this one or this one? What's the difference between the S formulas and the A formulas? The S's deal with adding, sum, I'm adding them up. This deals with just a term. Which term in the list? Okay, is the bug bothering you now? Oh, I see it. It is, I think it's off. Looks like I'm off. Okay, it's all right. I think you'll be okay. But it did come over here somewhere. Oh, there it is. It is. It's a little. It's dead now.
I've never seen somebody come out so fast.
Okay. Anything for you, Jordan. Anything for you.
Mrs. Ford,
right,
there's
let's
another
look at
one.
number 3.
Mrs. Ford, there's another one. Can I get it?
Are you kidding me?
It's right here, but it's
Smash it.
got him.
Okay, so 3 3/2, 3/4, 3/8. I'm looking to see because we actually did have, this is kind of gross, but a couple classrooms down, they had an infestation. Okay, we don't have that. Maybe we just stopped the infestation, we just killed mom and dad.
Exactly.
All right, take a look at it. Your job is to find the sum. Okay? Arithmetic or geometric? I heard geometric. If it's geometric, I have to be multiplying by something. What am I multiplying by? 1/2. Very good. I'm multiplying by 1/2. And it says find the sum. So geometric sum would be right here. But there's a problem. Can you tell me, did you read the question? What's the problem? Do you see a problem with that?
It says it's an infinite.
It says it's infinite. Now what does infinite mean? Infinite means it goes on forever. Which means I don't have an end. That n tells me to add up the first 90, S sub 90. Add up the first 200, S sub 200. If it's infinite, then I don't have an n. I don't know what n is just going. So our formula for an infinite geometric series is right here. Notice that that formula has an R, because it's geometric, it has an R, but it does not have an N. So basically, it got rid of this part of the formula because that part of the formula has an N in it. So it's not that, it's just this over this. Can we do that problem now that we know we have a formula? Well, what will S equal? What's A sub 1? 3. What did you say your ratio was? 1/2. 1/2. So that's 3 divided by 1/2? No, it's not 1.5. It's actually 6. So if you're going to type that into your calculator, this has to be in parentheses. Okay? That has to be in parentheses. Or you could change it to 0.5 and do 3 divided by 0.5. And for you.
Cut it out.
This is the easiest formula to use. So let's see if we can squeeze in a couple more. What is the ratio in problem B? What am I multiplying by? Negative 1/2. I love it. Whoever said that over there is awesome. Negative 1/2. Negative 2 divided by 4. 1 divided by negative 2. That's 1/2 negative. So what is your sum? The first term is 4 divided by 1 minus negative 1/2. So be careful. 4 divided by 1.5, 1.5. And what is that? 4 divided by 1.5 is
6, 7.
let's fraction it. 8/3. I divided it in, I got a decimal that went on forever, I hit math frac and got 8/3. One more and we'll be done for the day. First term is 6, I need my ratio. What is my ratio in problem C? I think it's really easy to see right here. What am I multiplying by to get from here to here? 2 over 3. If I take this times 2 over 3, you're gonna get 8/3. So my ratio is 2/3. You gotta think. It's not just gonna fall into your lap. You gotta spend some time thinking about it. So that's 6 divided by 1/3. If you type that in just like that, which you can, this has to be in parentheses. And that's 18. 6 times 3 is 18. Yes, so the answer to that problem is 18. Tomorrow, I don't see you. So next time I see you, we will finish up this. We'll spend a day reviewing and then we'll take a quiz. And then we'll start chapter 8, the last chapter. I will assign 9.5 next time, so that homework will be due on Thursday. Tell me what. What do you get out of that?
All right, so before prayer, I want to give you a little reminder to bring a towel or blanket to sit on tomorrow. We will be doing the living spaces outside, and the grass may be a little bit wet. So again, please bring a towel to sit on and the grass. If you prefer it, let me know. Now, as we come to the end of the day, let's pray and Holy Cross and be in the name of the Father, Son, and Holy Spirit. Amen. Hail the cross.
Our Lady,
With her leading,
we shall not tire.
Our Lady of the Hill, pray for us. In the name of the Father, Son, and Holy Spirit. Amen. Watch the message.
Charlie's last night in the room because he stood up before the end of prayer.
Me?
Yes, you.
My bad. I don't know.
Not this time. I made sure of that. I was like, I don't know about that.
Oh, so you're gonna miss Tuesday? And, I don't have any plans. So if you're not, it's okay. We'll get it done.
Oh, yeah, I didn't.
Yeah, good luck. Good luck.
Is there any, like, practice quiz I need?
You know, actually there is, but I don't have it run off yet.
Okay.
So it's in Canvas,
Okay.
but I don't have it. They're right here and they're in my pile to do. So you won't be here at all tomorrow?
No.
Okay. All right, and you won't be here probably very long tonight. Charlie, you can go, you can go.
No, I won't.
Okay, so, I'm sorry, I don't have them ready. You know, if there's somebody that can bring you one, that's fine, or you can just bring out Candace.
Okay.
Charlie.
Ready to take the test.
Okay, so you're taking, all right, if you're here to take a test, your phones go in the caddy, get your phones put up, it's already done, great. Great, you can sit right here, and you are taking this test that we just took. You need a calculator for the whole thing, use your calculator for the whole thing. Abby, you are doing the same thing,
Yeah, I already filled up.
and is this what you are doing, Lincoln?
Yeah.
All right, put everything away, except your calculator. And here we go. And I have to put in my attendance, Becca, and then I will be ready for you. You need to put all those papers, okay?
Yeah, that's all just trash.
Okay. All right, so let me put in my attendance for last period. I gotta remember to turn off the video.
Oh.
So we got a whole bunch of